Hi, this is Mr. Caslin. We're going to go over an SAT problem that I found. At first it looks, especially for you non-geometry people, it looks kind of scary actually. We're looking for the total shaded area of this circle. Well, the problem is we have this really strange shape in the middle that's not shaded, and that doesn't look like something that I would even know how to find the area of. But this problem's not as scary as it looks if you follow the clues. It talks to the fact that there's all of these shapes are made up of semicircular arcs. For example, the arc AB forms this semicircle. Well, we can work with that. The arc AC forms this semicircle. Okay, these semicircles are going to help us solve this problem. First thing you need to know is the formula for the area of a circle. You're going to need to know that for SAT. Area is equal to pi r squared, something you've been working with for a while. Alright, there are more than one way to solve this problem, but let me show you my approach. I'm going to treat this entire circle as shaded to begin with. Let's see what the maximum area would be if the entire circle was shaded. So we're going to use our pi r squared. So area is equal to pi times the radius. Now, remember the problem says here that you've got 6 equal parts, and parts are equidistant from each other. Equidistant means the same thing. So pi r squared. It means the radius of the overall circle here is 1, 2, 3. So now we know we're dealing with pi times 3 squared. So the overall area of the entire circle is 9 pi. So we know it's going to be less than 9 pi because we have this non-shaded piece on the inside. We can eliminate these two answers. There's no way that shaded area can be more than 9 pi. So let's get rid of answers D and E. Okay, next up, strategy. Usually in this type of problem we would subtract out the non-shaded area. Since the non-shaded area is a shape we're not sure how to deal with, what we're going to do next is we're going to think about this semicircle right here. We're going to treat this entire semicircle as if it was non-shaded, and we can subtract that out. Now keep in mind you've got a semicircle on the other side that is the same size, so if you put those two semicircles together it would form a nice circle with a radius of 1, 2. Okay, remember we're going to treat all of this as, let me shade it here to show you, we're going to treat all of this as non-shaded area, okay, and subtract it out. We said the radius was 2, so we've got pi times the radius squared. So 2 times 2, we got 4 pi. We're going to subtract that out, and if all of this yellow was non-shaded, the area of the shaded piece would be 5 pi. Alright, not quite done yet because now we have to deal with this semicircle here and this semicircle here. Those are shaded, so we're actually going to add those shaded pieces back in. So we have this shaded area here. The radius happens to be 1, and we have the same size semicircle over here. If we put those together, it would form one solid circle. So we're going to add in pi times 1 squared. You have to excuse me, I'm still writing with my mouse, which I'm not great at yet, so excuse my writing. But we're going to add in 1 pi, which is, well, it's 1 pi. 1 pi plus 6 pi is equal, excuse me, I'm jumping ahead to the conclusion. 5 pi plus 1 pi is 6 pi. The answer to this problem turns out to be C. Okay, so don't worry about the fact that it looked like we have this two-dimensional squiggle, if you want to call it that. We didn't have to work with that. What we ended up working with was semicircular arcs. And then remember, it's the problem's giving you that clue. You didn't have to figure that out all by yourself. The nice thing about videos is you can watch this a couple times. If you didn't get it the first time, watch it a couple times, and it will, hopefully the solution will come to you. Till next time, thanks.